we've seen that there are two criteria for acceptable arguments: well-groundedness and validity. We've also seen that there are two types of arguments: inductive and deductive. So far, we've examined some aspects of informal logic, that is, analysis of the well-groundedness of arguments. And we've looked at validity concerns for inductive arguments. What remains for us is deductive validity. This is the aspect of logic that has historically commanded a great amount of attention from logicians, in part because of its use in mathematics, and in part because it's the study of what we can know with absolute certainty. There's a long trail of work in formal logic. The first figure in the history of thought to give us a functional formal account of reasoning was Aristotle. Possibly the smartest person to have ever lived, Aristotle provided us with the starting point of virtually every academic discipline, from economics and physics to literary theory and ethics. But for us, it's his work on categorical logic that's important. Now, ancient commenters grouped his 6 logical works into a collection they called the Organon, or instrument, the idea being that formal logic is the instrument of the philosopher. Now, by the word philosopher in this context, we mean something more broad than our contemporary meaning. The scientist was considered a natural philosopher, for example. So, the Organon was meant to provide the instrument for all human reasoning. Through the influence of Thomas Aquinas, Aristotle's work became sanctioned church doctrine, and thus he was studied deeply in the early universities, which were church-based institutions. As such, some of what we call Aristotelian logic is from Aristotle himself, and other elements come from classical students, while further aspects are from the Neo-Aristotelian Catholic tradition. But it all starts with categorical propositions. Aristotle's logic begins with a little bit of grammar. Formal logic examines what propositions necessarily follow from what other propositions because of their forms. Propositions need to be expressed as declarative sentences, and declarative sentences, Aristotle contends, have a specific form. All declarative sentences that we will consider have a subject and a predicate. The subject is what the sentence is about, and the predicate is what we're asserting about the subject. A sentence is true if and only if the subject does have the property asserted by the predicate, and it's false if the subject does not. These categorical sentences come in 4 types. First is the universal affirmative. Sentences of the form, all A's are B's. All people have noses. All frogs can jump. All logicians are good-looking. Second is the universal negative. No A's or B's. No circles have angles. No fish have ears. No dogs are allowed. Third is the particular affirmative. Some A's are B's. Some people are blonde. Some comedians are funny. Some trees are deciduous. And finally, there's the particular negative. Some A's are not B's. Some wines are not expensive. Some music is not tonal. Some days are not Fridays. We arrange these sentences into what we call the square of opposition. The top line is for universal sentences. The bottom line is for particular sentences. The left side is for affirmative sentences. The right side is for negative sentences. We have abbreviations for each. Universal affirmative sentences are called A sentences. Universal negations are called E sentences. Particular affirmative sentences are I sentences, and particular negative sentences are called O sentences. Not only are these the first 4 vowels in alphabetical order, but A and I are also the first 2 vowels of the Latin words affirmo, or to affirm, and E and O are the first 2 vowels in the Latin word nego, or to deny. The first vowel corresponds to the universal, and the second to the particular. The reason we call this the square of opposition is because opposite corners, sentences that are connected diagonally on the square, are negations of each other. That is, an A sentence is true if and only if the O sentence is false. All Boy Scouts are boys if and only if it's not true that some Boy Scouts are not boys. Similarly, if it's false that all Boy Scouts are boys, then there must be some Boy Scout that isn't a boy. A and O sentences will always have different truth values. And it's the same for E and I sentences. If it's true that no clowns are happy, then it's false that some clowns are happy. And if it's true that some clowns are happy, then it must be false that no clowns are happy. E and I sentences must have different truth values. The sentences on opposite corners are called contradictories because they contradict each other. One and only one can be true at a time. But this is not the case with A and E or I and O sentences. A and E are called contraries. They cannot both be true, but they can both be false. It's false that all paintings use the color blue, and it's false that no paintings use the color blue. I and O are called subcontraries. They can both be true, but cannot both be false. It is true that some people are having a birthday today, and some people aren't. But if it's false that some A's are B's, then it must be true that some A's are not B's. We should be very careful here with our words. When we say some in our I and O sentences, what we mean is at least one, maybe all. By using the word some, we are not saying that only some but not all. It may be simultaneously true that all people have mothers and that some people have mothers. The word all is slightly more complex. By all, we mean every member of the category. But what about peculiar categories which are empty? Consider the A sentence, all unicorns have a horn. Is this sentence true or false? It seems to be true by definition. To have a horn is part of what it is to be a unicorn. But at the same time, there are no unicorns for the sentence to be true of. So how do we make sense of it? The answer is that we have two different meanings, the hypothetical viewpoint and the existential viewpoint. In the hypothetical viewpoint, the sentence, all unicorns have a horn, is true because it means all unicorns, if there are any, and there might not be, have a horn. From the existential viewpoint, the sentence, all unicorns have a horn, is false because it now means there are unicorns and all of them have a horn. We need to know whether we're working with the hypothetical or existential viewpoint before we start doing our logical manipulations. Notice one important difference. From the existential viewpoint, A sentences imply I sentences, and E sentences imply O sentences. If every dog has his day, then some dogs have their days. If no square has 5 sides, then some squares do not have 5 sides. As long as we know the subject exists, then if the predicate holds for all, it must hold for some. But from the hypothetical viewpoint, just because an A sentence is true does not mean that the corresponding I sentence is true. In the hypothetical viewpoint, it is true that all griffins have the body of a lion, but that doesn't mean that some griffins do, because the word some means there is at least one, and the griffin is a mythical beast. There aren't any. So, with vacuous subjects, we can have true A sentences and false I sentences, or true E sentences and false O sentences. Both viewpoints are legitimate, but for clarity's sake, let's assume the hypothetical viewpoint unless otherwise noted. Recall that our interest here is deductive validity. We want to know when we have to believe a conclusion if we also believe the premises. For Aristotle, the key to reasoning is a type of argument called a syllogism. A syllogism is an argument with two premises. Categorical syllogisms are arguments with a categorical sentence as a conclusion and two categorical sentences as premises. For example, all humans are mortal, all Greeks are human, therefore all Greeks are mortal. That is a categorical syllogism. Okay, a little terminology here is necessary. The conclusion has two terms, a subject and a predicate. The subject of the conclusion is called the minor term. The predicate of the conclusion is called the major term. In our example, Greek is the minor term and mortal is the major term. There's another term that appears in both premises, but not in the conclusion. This is called the middle term. Human is the middle term in our example. The premise with the minor term and the middle term is called the minor premise, and the one with the middle term and the major term is called the major premise. We always write our major premise first. Our example has a major premise that's an A sentence, a minor premise that's an A sentence, and a conclusion that's yet another A sentence. Reading top to bottom, we say that this argument has the mood AAA. AAA syllogisms are nice because if they turn out to be invalid, you can call for a free tow to the nearest garage. But notice that we can have different variations of AAA. Compare our example with the new one. All humans are mortal, all Greeks are human, therefore all Greeks are mortal. All Greeks are human, all humans are mortal, therefore all mortals are Greeks. These two arguments both have A sentences for premises, but because the terms are switched around, they're different arguments. Indeed, the first example is valid, but the second is not. I'll show you how to determine this in a couple minutes. The point, though, is that the order of the terms matters. There are four possible arrangements of the terms. We call each arrangement a figure. The first figure has a major premise that starts with the middle term and a minor premise that starts with the minor term. The second figure has a major premise starting with the major term and a minor premise starting with the minor term. The third figure starts both premises with the middle term, and the fourth figure starts the major premise with the major term and the minor premise with the middle term. This is a complete catalog of possible figures. Combining mood with figure, we get a complete list of the possible forms of categorical syllogisms. For example, some dogs have 4 legs, and some 4-legged beings are not cats, therefore no cats are dogs. It's a silly example, and intuitively we sense that it's invalid, but put that aside because right now we're just worried about naming it correctly. Now, the major premise is an I sentence. Some dogs have 4 legs. The minor premise is an O sentence. Some 4-legged beings are not cats. And the conclusion is an E sentence. No cats are dogs. So, the mood is IOE. The middle term appears second in the major premise and first in the minor premise. So, it's a figure 4. We have an argument that is IOE4. Go back to our original argument. All Greeks are human. All humans are mortal. Therefore, all Greeks are mortal. It has a mood of AAA. And the middle term is second in the major premise and first in the minor premise, so it is an AAA1. We have 4 possibilities for the major premise, AEIO, and the same 4 possibilities for the minor premise and the conclusion. This gives us 4 times 4 times 4, or 64 possible moods. We then have 4 figures for each mood, giving us 64 times 4, or 256 categorical syllogisms whose validity status we need to determine. How do we do that? It turns out that there are 5 simple rules that detect the 15 valid forms from the hypothetical viewpoint. But before we work with the rules, we need to understand one more concept, a distributed term. Now, a term in a categorical sentence is distributed if that sentence says something about the entire category the term refers to. So, in an A sentence like, all Greeks are human, the subject is distributed because it tells us something about all Greeks. Likewise, in an E sentence like, no cowboys are werewolves, we're told something about the entire class of cowboys. So again, the subject is distributed. In an I sentence like, some people are allergic to peanuts, we're not told anything about any entire class, so no term is distributed by an I sentence. In an O sentence like, some computers are not made by Apple, it seems intuitively that, like with the I sentences, neither term is distributed, but in fact, the predicate of an O sentence is distributed. We know of the entire category of products made by Apple, that it fails to include some computers, say the PC I have at work. So, O sentences distribute the predicate, A and E sentences distribute their subjects, and I sentences distribute nothing. Having this concept, we can now set out the 5 rules. 1. In all valid syllogisms, the middle term is distributed in at least one of the premises. 2. In all valid syllogisms, any term distributed in the conclusion is also distributed in the premises. 3. In all valid syllogisms, at least one of the premises must be affirmative. 4. In all valid syllogisms, if the conclusion is negative, one premise must be negative. 5. And this one's for the hypothetical viewpoint only. For the existential viewpoint, just use the first 4. So number 5 is, in all valid syllogisms, if the conclusion is particular, at least one of the premises must be particular. A syllogism is valid if and only if it satisfies all 5 of our rules. Violate even one, and out you go. Invalid argument. So, let's try out these rules on some of our examples. We had all humans are mortal, all Greeks are human, therefore all Greeks are mortal. Recall that this is AAA1. Now, Rule 1 says that the middle term must be distributed. Our middle term here is human. Notice that in our major premise, human is the subject, and it's an A sentence. A sentences distribute their subjects, so Rule 1 is satisfied. Rule 2 says that anything distributed in the conclusion must also be distributed in the premises. Our conclusion is an A sentence, which distributes its subject. In this case, Greeks. But our minor premise is also an A sentence with the subject Greeks, so we see the term distributed in the conclusion, also distributed in the premises. 2 is a go. Rule 3. At least one premise must be affirmative. Both are, so check on that. Rule 4. If the conclusion is negative, one of the premises must be. But our conclusion's affirmative, so no worries there. Finally, Rule 5. If the conclusion is particular, one of the premises must also be. But our conclusion is universal, so again, no worries. We've met all 5 requirements. So we can say with absolute certainty that AAA1 is valid. If the premises are true, the conclusion must be also. Let's try our second example. All Greeks are human, all humans are mortal, therefore all mortals are Greeks. This is AAA in mood, but it's figure 4. It's AAA4. Is AAA4 valid like AAA1? Well, Rule 1 says that the middle term has to be distributed. Our middle term again is human, and our minor premise is an A sentence with human as its subject. A sentences distribute their subjects, so Rule 1 is satisfied. Rule 2 says that any term distributed in the conclusion must be distributed in the premises. Our conclusion is an A sentence. All mortals are Greeks, and A sentences distribute their subjects. So, in the conclusion, the class of mortals is distributed. However, this is our minor term, which is not distributed in the minor premise. Rule 2 is violated, and we can say that AAA4 is invalid. If the premises are true, we still know nothing about the truth or falsity of the conclusion. How about our last example? Some dogs have 4 legs. Some 4-legged beings are not cats. Therefore, no cats are dogs. Again, this is IOE4. Let's apply our rules. Rule 1, the middle term must be distributed in at least one of the premises. The middle term here is having 4 legs. Our major premise is an I sentence, and I sentences distribute nothing. Our minor premise is an O sentence, and O sentences distribute their predicates, which here is cats. So the middle term is not distributed, and therefore we know that IOE4 is also invalid. These rules work. but they're not terribly intuitive, right? We can determine which categorical syllogisms are valid and which are not, but we come away without a sense of why. It would be nice to have a method that really allows us to see why a categorical syllogism is or is not valid. Fortunately, we have one. It was provided by the 19th century English logician John Venn. He came up with a way of visually representing the content of each type of categorical proposition in cute little diagrams that forever bear his name, Venn diagrams. We start with a pair of overlapping circles, with the one on the left representing the subject class and the one on the right representing the predicate class. The area in the overlap is the part of the subject class that is also in the predicate class. The parts of the circle outside of the overlap are for members of the classes that belong only to one or the other class. We indicate that a region is empty by shading it in, and we represent that an area is not empty by putting an X in it. Let's start with our A sentence. All A's are B's. We have our two circles, with the left one representing all A's and the right one representing everything that's a B. When we say that all A's are B's, what we're saying is that the entire contents of the A class is also in the B class. In other words, if there's anything in the A class, then we know it has to be found in the intersection. The section of the A class outside of the overlap is empty since there are no A's that are not B's. We thus draw the Venn diagram for A sentences as interlocking circles with the part of the A circle outside of the overlap shaded in. For E sentences, no A's or B's. What we're saying is that if there are any A's, we know they're not B. Pictorially, this means that the part of the A circle that is in the overlap is empty. The Venn diagram for an E sentence is two interlocking circles with the overlap shaded in. For I sentences, some A's or B's, we're saying that there is at least one thing that is an A and also is a B. We represent that thing with an X, and since it must be both A and B, we put the X in the overlap. This is the Venn diagram for an I sentence. In the case of O sentences, some A's are not B's, we're saying that there's at least one thing that is an A, but is not a B. When we represent this graphically, we're saying that there is a thing, represented by an X, and that's in the A circle, but not in the B circle. We put the X in the A circle outside of the overlap. For categorical syllogisms, we just enter in the information from the larger premises into a larger diagram that has three circles. One for the minor term on the bottom left, one for the major term on the bottom right, and one for the middle term placed above and appropriately in the middle. We enter the premises and see if what comes out contains the information within the conclusion. If it is, then the argument is valid. If not, it's invalid. Let's try our three examples again and see that we get the same results. Now, the first was, all humans are mortal, all Greeks are human, therefore all Greeks are mortal. Now, we have three circles with the one on the bottom left representing the minor term of the conclusion, Greeks. The bottom right circle representing our major term, mortal, and the middle circle for our middle term, human. We start with our first premise, which is the A sentence, all humans are mortal. That means that the part of the human circle that's not part of the mortal circle is empty, and so that region is shaded. Our second premise is the A sentence, all Greeks are human. That means that the part of the Greek circle that's not part of the overlap with the human circle is empty, and therefore it gets shaded. Now, we look at the circles in the bottom and ask whether the information in our conclusion is fully contained there. Our conclusion is that all Greeks are mortal. So we need to see if the part of the Greeks circle that lies outside of the mortal circle is shaded. Lo and behold, it is. This is a valid argument, and we can show it using Venn diagrams. It's true that more is shaded, but this is fine. Our premises give us more information than the conclusion. That's no problem. Remember that we're looking at deductive validity here. That is, if the premises are true, does the conclusion also have to be true? If other sentences are also true, no problem, but not our concern. Are we required to believe the conclusion if we believe the premises? And in this case, we are. How about our second example? All mortals are human, all humans are Greek, therefore all Greeks are mortal. Now, we have the same circles in the same places, but our first premise now is the A sentence, all mortals are human. That means that the section of the mortal circle that's not part of the human circle is empty, and that gets shaded in. Second, the A sentence, all humans are Greeks. This means that the part of the human circle that's not part of the Greek circle is empty. It too gets shaded. Now, we look to see if the information in our conclusion is present in the diagram. Our conclusion is the A sentence, all Greeks are mortal. So, for this argument to be valid, we need for the part of the Greek circle that's not part of the mortal circle to be completely shaded. And it's not. Might it be empty? Maybe. Maybe not. We don't know. And so we are not logically compelled to believe the conclusion based upon the information in the premises. The argument is invalid, just as our rules told us. Now, let's try our last example. Some dogs have 4 legs. Some 4-legged beings are not cats. Therefore, no cats are dogs. Okay, we have some new types of sentences here. First, set out our circles. Cats on the bottom left, dogs on the bottom right, 4-legged things in the middle. Our first premise is the I sentence, some dogs have 4 legs. That means that there exists at least one thing that is both a dog and is 4-legged. As such, we need to represent this thing with an X in the overlap between the dog and 4-legged circles. But which part of the intersection? The region is now divided because we have a third circle. Which part does it go in? We don't know. The diagram has to be an accurate representation of all and only what we know, so what should we do? We'll put the X on the arc dividing the two regions. This will signify that there's an X somewhere in there. Might it be in the middle? Maybe, maybe not. Might it be in the outer section? Maybe, maybe not. We don't know. Our second premise is an O sentence. Some 4-legged beings are not cats. That means that there exists at least one thing that is a member of the set of 4-legged things, but is not a member of the set of all cats. We put an X representing this thing in the 4-legged circle outside of the cat circle. But is it in the part that's also a part of the dog circle or not? It doesn't tell us. So again, the X goes on the line. Now, does the diagram provide us with all the information contained in the conclusion? The conclusion is the E sentence, no cats or dogs. That would be represented by having the intersection of the cat and dog circle completely shaded in. But no part of the overlap is shaded in, so the premises do not contain the information in the conclusion. And just as we saw with our rule method, this is an invalid argument. We see in formal logic that we're able to develop rigorous methods by which we can tell with absolute certainty whether a conclusion must be true given the truth of the premises. That certainty and the methods to determine it are the hallmark of deduction.